The observable universe is 93 billion light-years across. That is the part we can see. The part whose light has had time to reach us since the Big Bang 13.8 billion years ago. Beyond that edge, there is almost certainly more universe, possibly infinitely more. But we will never see it. We will never reach it. We will never receive a signal from it or send one to it, not because of any limitation of technology, because of physics itself. And that is perhaps the strangest fact in all of science. To understand why, you need to understand what the observable universe actually is. It is not a bubble of matter floating in empty space. It is a horizon, a limit of information. The farthest distance from which light has had time to travel to us since the beginning of everything. Light moves at roughly 300,000 kilometers per second. The universe is 13.8 billion years old. You might expect, then, that the observable universe extends 13.8 billion light-years in every direction. But it is larger than that, much larger, because space itself has been expanding the entire time. The light from the most distant objects we can detect was emitted 13.8 billion years ago, but those objects have been carried away from us by the expansion of space ever since. By now, they are roughly 46.5 billion light-years away, in every direction. That gives us an observable universe with a diameter of 93 billion light-years. Within it, there are an estimated 2 trillion galaxies, each containing hundreds of billions of stars. This is already an incomprehensible number. But it is only what we can see. The total universe could be vastly larger. Some theoretical models suggest it could be 250 times the diameter of the observable part. Others suggest it could be infinite. We do not know, and we may never know. Here is why. The expansion of the universe is accelerating, driven by a force we call dark energy, a name that is essentially a placeholder for something we do not understand. The space between distant objects is stretching faster and faster. This means that objects near the edge of our observable universe are currently moving away from us faster than the speed of light. That statement sounds like it should be impossible. Nothing can travel faster than light. But this is a common misunderstanding. The speed limit applies to objects moving through space. Space itself has no speed limit. It can expand as fast as it likes. And at the very edge of the observable universe, it is expanding faster than light can cross it. The practical consequence of this is devastating and permanent. Any signal we send toward those distant regions will never arrive. The space it is traveling through is stretching faster than the signal can cross it. It is like trying to walk to the far end of a hallway that is growing faster than you can walk. And any signal sent toward us from those regions will never arrive either. The photons are traveling at the speed of light, but the space they need to cross is expanding faster. This means there are regions of the universe that are permanently, physically, mathematically inaccessible to us. Not temporarily, not until we build better technology, permanently. The laws of physics themselves make it impossible, and the situation is getting worse. Because the expansion is accelerating, the observable universe is actually shrinking in a meaningful sense. Galaxies that are currently within our observable horizon will eventually cross the threshold and disappear. Their light will redshift beyond detection. Their signals will stretch into nothing. Over billions of years, the night sky will go dark. Not because the stars have died, though eventually they will, but because the galaxies themselves will have been carried beyond the edge of our observable universe by the expansion of space. In the far future, an astronomer looking up from a planet in the Milky Way will see only the local group of galaxies. Everything else will have been stretched beyond the cosmic horizon. There will be no evidence that the broader universe ever existed. A civilization born in that era, without access to our historical records, would have no way of knowing that the universe was once filled with trillions of galaxies. They would look out and see a small island of stars surrounded by an infinite void. And they would believe, reasonably, based on all available evidence, that this was all there is. This is a genuinely unsettling idea. The universe is not just expanding, it is erasing its own history. information is being permanently lost. Not destroyed in any violent sense, simply carried beyond the reach of any observer, the cosmic equivalent of a book being moved to a shelf so far away that no one will ever read it again. And there is one more layer to this that makes it stranger still. We do not know the shape of the total universe. If the universe is flat, as current measurements suggest, it could extend infinitely in all directions. An infinite number of galaxies, an infinite number of stars, an infinite number of planets. In an infinite universe, every possible configuration of matter occurs somewhere. This means that somewhere, unimaginably far away, there is another arrangement of atoms identical to you, reading identical words, thinking identical thoughts. This is not mysticism. It is a straightforward consequence of infinity and probability. Given enough space and enough matter, repetition is inevitable. But those copies of you are so far away that no signal could ever bridge the gap. They exist in a mathematical sense, but they are as unreachable as if they did not exist at all. The universe may contain everything, and we may be able to access almost none of it. What we see when we look at the sky is not the universe. It is a tiny fraction of the universe, visible to us only because of the accidents of timing and proximity. A keyhole view of something immeasurably larger, and the keyhole is closing. This is the situation we find ourselves in. We live on a small planet, orbiting an ordinary star in an unremarkable galaxy, inside a sphere of observable universe that represents an unknown and possibly infinitesimal fraction of reality.